Right, compact laptop motherboard here. Power on no display. All the voltage is like the your 5 volt, 3 volt, your RAM supply, the CPU core, the GPU V core. Those voltage are present basically. So, and I'm not getting any display. So I've reprogrammed the BIOS because it could be the BIOS that the first thing to look at is to sort of see if you can do that, tackle that side of it, which I have already done. That hasn't resolved the problem, sadly. So let me sort of just check something. Yeah, that was done, absolutely. Just been busy, so couldn't exactly remember what's going on. I just left it for about a week or so. So yeah, the BIOS was reprogrammed. No thingy basically. The problem hasn't been solved. So I've taken all this. I've dismantled the whole unit. I don't want to go through the process. If the laptop is working and the board is posting display, you'll see the cap locks there as soon as I press the LED there. Or as soon as I press the cap locks on the keyboard, right? So let's power on this sucker. Okay, so we've got white light. You can see that. Okay, I'm pressing the keyboard, the key, no cap locks. Okay, so that means that the laptop is not posting. It's the quickest way of checking. When the LED light lights up when you press the cap locks on the caps locks LED, wherever it is on your keyboard, you know that the board has posted and it's displaying image, right? So what's it gonna be? Oh yes, a graphic chip repair. That's what it's going to be. A job a lot of people don't want to get involved with. It is a bit of a troll, so I'm not going to deny that, but I've been at it for a very long time, so I know what I'm doing. The graphic chip what I have here is an AMD. Okay, and I will ground myself before static, using the static from my body to fry the shit out of this chip. I'm not so happy about the date codes on them, because I don't know if AMD is still manufacturing this to that date, so it could even be just an old trick from the Chinese supplier. But I tend to use golden chipset, and I've not had much problems with them. When I say much, maybe just one occasional problem, but otherwise they've been absolutely fine, so I would recommend to try them out. Okay, so what's going to happen now is I will be taking the video in small snapshots. It's not going to be a full video from start till end, because that can take several hours of recording and all that, and probably take me a full entire 24 hours to upload it on YouTube. So it will be done in small stages. What's next is that the board's going to get stripped apart. All the plastic things are going to get taken off, like these films. The heatsink's got to come off, and let me power this off. Okay, and put it in a baking oven, which is a toaster oven, around about from 90, I'd say about 90 degree to about, yeah, roughly about 90 degree to about 120. I'd stay safe with 90 only because that this board contains capacitors that I've got to be careful with. So these capacitors, I'm not introducing too much temperature on them, because they will start bulging and all that. So I would say around about 85-90 degree Celsius. JDEX recommendations round about 120 for about 24 hours at least to 48 hours. I haven't got that sort of time frame. The whole idea is that to sort of give the board, warm up the board. That's all it is. It's like warming up a car engine before you start ragging it for 50, so that's my way of understanding. I'm not going to sort of leave this in a baking oven for more than 2 to 3 hours basically. So I will start by peeling the RAM sticker off. Heatsink's got to come off, and we'll take it from there. So yeah, I'll record the next stage, and we'll go from that one to another basically. So yeah, there has been a little change of plan basically. After inspecting the heatsink, usually the common problem is that this chip will die because of overheating. Now when I had a quick closer look at this heatsink, it seems to be nice and clear. I'm just trying to see if I can take off the fan. So because this is the first time the fan's been opened, so it's not been touched before. So let me show you that. When I said the change of plan, I'm likely to reflow the chip rather than replacing it. See how we go on with it. Only reason being is that, yes, it may have overheated and killed itself, or it might just be more likely chances a dry solder joint somewhere. Now, if it's killed itself, then definitely a reflow is not going to be a proper fix. But if it has, take this sync up. If it's somehow overheat, you know, if it's somehow got a dry solder joint, which I believe is the case, then it's worth sort of running a reflow and sort of take it from there basically. So let me show you something. Okay, like I said, this has not been opened before. It's the first time, and as I said, if there's dust build up in these fins, then yes, it's overheated, it's killed the chip. But if there is very little dust behind there, the chances are that there may be a dry solder joint under the BGA chip. I do have an inspection tool, but it's not good enough to sort of show the crack in the soldering basically. I don't think it is, so it's one of those things. So let's find out what's going on. See, so there's only bare minimal dust. That couldn't have overheated the chip, right? So a couple of things. Chip could have just died all by itself, or there's a dry solder joint underneath. So what I'm going to do is I'm going to run a reflow on it first, see how you're going with it. If that doesn't resolve the problem, then the board's got to go back in the machine again, and I will be running I'll be going through replacing the chip. Is it worth them either? Of course it is, because there's a lot more work involved in taking the chip out and all this and that, and this could perfectly be a good working chip. So we'll see anyway. Yeah, just pre-pepping everything basically. I've not done the body yet, but I'm just giving this a clean and just keep it in the storage thingy. I've cleared the fan and everything out, so that's nice and clean. Got rid of all the old thermal paste. I will be applying a new thermal pad onto the GPU once I've done. Usually I'd put I'm probably going to measure the distance between, well, the thickness of the pad, and possibly put a shim underneath it, and then put a small layer of paddings. But if it's only a small thingy, then if it's very thin, then I'm not going to bother with the copper shim basically, because you've got to be careful when you're using those shim. You know, sometimes they heat sink, so sometimes this surface, when it makes a contact with the GPU, it's not flat. So what that effectively means is that you could one side of the shim will make contact, the other side will absolutely make no contact, which means that chip will sort of overheat and die. So the smartest thing to do is use a thermal pad if you can. I think that would be the best way around, but it's finding a decent thermal pad is another question in itself basically. I think Zakasa used to do them. I used to get them off Micro Direct on Upper Book Street, Manchester, but they're shot. I've got loads of them left somewhere in the tub, but that's not issue. There's plenty of thermal pads here basically, but I just want to use anything that I can find that's good quality, so I know that what it says. Look at all these pads, and there's various ones in there. That's not a problem. The issue is that just mentioning that you need something that's branded would help. Okay, so let's I'll be taking all that off, and obviously the edge bonding's got to come out. If you can see that, let's just see how I do that is through let's get this bloody camera angle, because I'm looking at it in an awkward thingy. See if you can see me what doing. Yeah, okay, so I'll be using heat and spraying around the edges to try and get rid of the glue. I'll be using a special tool, Kyalani or whatever it is, however way you want to pronounce it. I will be using that tool to try and spray under the chip, the corner of the chip, because you could have a little bit of edge bonding stuck on the edges here underneath the chip, and that could sort of cause a lot of problem when you're trying to nudge the chip once you've done a successful reflow. So what I will be using is this sort of things, and under the microscope, just nice and gently scrape underneath it and get rid of anything that's left. But obviously you've got to apply heat and everything, so these kits, I bought tons of them. I think I bought the lot basically, one after another. So just see. yeah, there's plenty of room for maneuverability. So okay, so let me start this and I'll take another clip and we'll take it from there. All right. Right, okay, so now I'm going to remove the edge bonding and just turn down the background music, because I'm pretty sure YouTube being YouTube will put a copyright strike on the video, and I think that's just going to do nothing other than just piss me off, basically. So let me grab a crocodile toothpick. Right, here we go. Okay, so my hands are going to be on the way, that's for definite, because so we'll just heat the corner up for about, set the hot air station to air to max at about 100 degrees Celsius. So 100 degrees Celsius. Okay. Yep, it's softening. I don't want my hands to be on the way, but I'll try my best. So we're all good and well this bit coming off, okay? But where the concern is that you've still got bits left under the chip, basically. The lot of it doesn't come in. So this is where I'm going to use that praying tool to try and sort of, a scraper or whatever you want to call it, to try and get any excess out. So that's one corner done. Let's move on to the next corner. I don't even see the purpose of putting them on, basically, because at this side only that bit's catching. That bit's got some attachment to the chip, otherwise no. Okay, so that's come off easily. The reason why I'm using toothpick is that I don't want to damage any of the traces. You know, just mistakes happens, and when the traces are damaged, you can get into a bit of a nightmare, basically, because the scraping will happen just right next to the Bga chip. Once you've reflowed, you've got to run all the jumper wires and all that business. Fuck it, I'm not doing all that. So it's kind of a preventative measure, basically, by using a cocktail stick, basically. And I bought loads of them, ton of them from a local cash and carry, because these don't sort of bend with the heat and all that business. Well, it will to a certain degree, but not to 100 degrees, basically. So let's warm this side up. That's gone off, and that's also gone off. Right, okay, so what I'm going to do now is get that little scraper, but you've got to be careful you're not putting excess amount of stress. Now the tip of this needs cleaning, actually, because I believe I've used it for something else before. So to give it a good clean, okay, just check both sides, give it a good clean with IPA. Okay, so that is nice and clean. And I'll start with the side where I've left. I'm just going to nudge it in. Yep, beautiful, absolutely beautiful. Because I've always struggled to remove edge bonding from under the chip. I couldn't find a perfect tool that can do this for me, but this is just a holy grail, basically. Look at that. Absolutely awesome. Don't press too hard, just nice and gently. Okay, so that's cool. Then I'm scraping the CPU socket. Right, okay, that side's done. Okay, well, when I say done, have I done? I don't think I've gone on the opposite side, have I? The beauty of it is that these blades are heat resistant, because it's metal. It's not going to bend, it's not going to do this, it's not going to do that, so you're perfectly fine. And this soft tin as well, so it bends, it flexes, which is a good thing. I'll do it. I'll start from this corner and I'll come round clockwise. So let's sort of do this one. Bonding's been removed now. and I think this is the cleanest by far that I've ever done, thanks to these tools manufactured by this company, Chinese company. Okay, absolutely awesome, man. Honest to God, this is I've been doing this for years, but this is the first time I can, I'm fully, I'm totally happy the fact that I can actually remove all the edge bondings right from the underneath, and probably try and see if I can get a glimpse of it on the camcorder. The piece of shit won't focus. Yeah, you get the idea. Alright, I've checked it, it's all clean. Prepping the board with the aluminium foil tape before sticking it into the baking oven. So let's cover this ram here. That's very important, that needs to be covered quite well. So do sort of remember that. I'm going to put a couple of layers of, in fact I'm going to put a bit of Captain tape over that. And then once I've done that, I'll put the thingy on. So let me grab a bit of Captain tape. Got various sizes of Captain tape, actually, plenty of them. I keep a plenty of stock of these sort of things because you never know when you're going to run short of supply. So I always, shit, it's okay. So I'll give that an extra bit of protection only because that's a very sensitive component, very sensitive component. Right, okay, let's get the foil back. DC jack can go back in the tray. No further use. I'm still debating whether to reflow this or put a new chip in. Just still sort of trolling me at the back of my mind, basically. So just leave the rest like this. As I said, I'm still debating that. Obviously, this is not a live stream, otherwise I would have asked you for your opinion on that. But I used to buy, and I still do buy, some of the stuff from Insat International, which is Jimmy at Insat International. Absolutely cracking guy. Sells a lot of stuff on Bga. I've not been on the website for quite a long time now. I don't know what the if things have been changed or whether new stuffs have come out. I don't know. I've not been on it. But if you want anything related to be graphic chip and like rework, not graphic chip, rework, like flux and all that business, solder balls, do sort of check his website, or he's on eBay as well. He's a friend, very nice man, very nice man. Been around to his premises countless times and always with warm. He sort of welcomed people with warm hands, it's just absolutely cracking man. So I mean, the more I leave exposed, the better it is, because the quicker the board sort of, then the chip heats up basically and the reflow process happens. The more aluminium reflective tape I put around, the more likely chances that it's going to take a bit longer for the profile to reach its optimal temperature, because what this reflector tape is doing is obviously is reflecting the infrared away, basically. So, and the reason why I'm hiding this component or covering this component is I don't want any components being exposed to any amount of heat, basically. That's just me, that's just the way I do my things. You others may have their own opinion, and I respect that, totally respect that, but when I'm doing something like a rework attempt on a graphic chip, sadly I am going to do things that best suits me. There's no particular instruction that works for everybody, right? This is just a reference. Basically, from my point of view, you do your things at your own discretion. Okay, now what I'm going to do is I'm going to apply a bit of reflective tape on top of these caps. There's a couple of them are here. I bloody hate these caps. I don't even know why they've been utilised. I mean, on the new board, this is an older board, but on the newer board I don't think I've seen any. So let's cover them up so I'm not exposing them to any level of heat. Grab a bit more tape. How many do I need? About 3, so okay. So yeah, you get the message. Yeah, you're probably thinking, what the fuck is all, what the crap is all that about, basically. All this foil and everything. Yeah, that's me doing the job properly, because you kind of get one good shot at this, maybe 2, to get the board working again. So, and I don't want to, I'm not keen on losing money. It's not about trial and error. It's about sort of making sure that this job is exercised to the best of my ability to try and make an earning. Because if I'm just doing it for the sake of doing it, then electricity, utilising the Jovi, my time, cost of the flux, cost of every electricity, everything basically, it all adds up. So me being me, things will have to be done my way or no way. Just kidding. Things has to be done in my way, properly. So here we are. Just left a bit of solvent to try and dissolve this glue, and then it'll get stuck inside a toaster oven for 2, 3, 4 hours, and I've got to nip out for a bit. So as soon as I get back, it'll be going on the rework machine. It's just been put inside the baking oven, as you can see there. Sadly, that's the best angle you're going to get, and I'll probably pull it out. Okay, there we go, with a little thermal couple and a temperature gauge here on the basically, and that will allow me to control and keep an eye on the actual temperature itself, basically. So it's critical that I don't allow the temperature exceed so much, only because of the fact that the risk of damaging those electrolytic capacitors are very high. So I'm not going to do that. Leave the chip on that side. I'm going to let this bake for, it's about what time? I'm going to go out now, so it's about a good couple of hours. So it's set to about 90 degree, but because of these toaster ovens are never accurate, I tend to keep it around about 70 where the marker is, and then slowly nudge it and observe the temperature basically, and then I know that in the region of 90, 95 is okay. I wouldn't want to hit anything above that. So that's all. Okay, so yeah, that's it. So it's going on to the yep, it's going on to the machine after. I'll keep you posted. Still baking the board. I would probably say it's been in the toaster oven for about 4 hours now, and the temperature's heating in the region of around about 90. So I'll just 86.9. So just toggle that on a little bit, so that'll start creeping up a little bit. Okay, so this is I think it's a 24 litre Cookworks toaster oven. I believe it is 24 litre, because anything smaller than that, the trouble you have is that you can't fit a decent size board, especially the older laptops basically. So and those are the ones that the older laptops are the ones that suffered graphic chip failures and things like that. So yep, just preheating the Jovi. I'm just going to leave that running for about 5 minutes. It'll just let the upper heater and the bottom heater warm up. As you can see, just about it's giving that red glare. Yeah, you can just about see the plates are warming up. So it is a crucial thing to do before you start running the profile. The motherboard is still in here. Okay, so now it's going to be the taking the chip off and replacing it. Now I'm thinking whether to replace the chip. More than likely I am going to do that actually. So there is the original chip, well, the new chip, the so-called new chip. We won't know until we put it on. I know it's a bit of a bullshit task, but everything in life is kind of bullshit, so what else there to add on? So, okay. Right, just applying flux. See if you can get this. This is the chip. I'm hopeful that you're getting all this, but it's just a pain on the fucking ass. Trying to get a view. There we go. Okay, so I've got an image. Okay, so I've actually just applied for some genuine Amtex flux around the chip. That's plenty, that. Okay, and I will keep that Amtex flux out. Just when it comes to specialized, jobs like this, I am sort of utilising the best flux on the market, which is Amtech. Just putting the probe over. Make sure that they're close to the chip, as close as I can get without going underneath, because these are very fine tip. Okay, let's get the top heater to my marking there. Alright, just make sure that the probe hasn't moved. Yeah, there will be a lot of noise on the background because I'm running so the board's already, without even running the profile, it's about 137 degrees Celsius. They go on the actual Jovi software. There you go. Okay, that's because everything's been kept warm, which is a good thing. I'm just going to start running the profile. So let's hit the button. The profile is running. Okay, so let's zoom out. It'll be fun finding the thingy. There you go. The profile has just begun. So we shall zoom back in where the chip is, and hopeful that that should. Let's just make sure that I'm not covering that light. Okay, I've let the temperature build up to about 200. Right, we've reached 205 degrees Celsius on one probe, and the other one's a couple of degrees less. Put the glasses on. The temperature's reaching quite rapidly because, well, there's a rapidly 1 degree, 2 degree per second. So I'm going to do a nudge test. $225, $217. Okay, so the chip is moving. Leave the operator running. Just jump in with the pump. Take the chip off. As easy as that. Okay. Now I can switch off the profile. Wait for the board to cool off a little bit. I could use my old trick of providing I can find that grain tool and start removing it from, collect all the solder balls here. Sadly I can't because some just left it too late, so no good with this one now. Okay, so what I'm going to do is leave the board where it is, as it is, let it cool down a little bit, and what I will do then is I'll use my Metcal soldering station to take off the solder balls from the pads. Looks like that I will be actually replacing the GPU and not reballing it, reflowing it. Reballing is kind of bullshit unless the chip you're reballing is in working condition. Otherwise, yeah, reballing is bullshit. Can I reach this? Yes, I can. The length of the cable is brilliantly long. So let's prepare my Metcal soldering station. Let's also take off that soldering station with a zip cleaner. I will be ready to go. I'm using these little zip cleaners, that's what I mean by that, okay? Something like this, you know, you can buy off the internet. Alright. What I'm going to do is apply a bit of leaded solder. Okay. The reason why I'm doing that is just to try and get rid of all the excess solder from the PCB. Okay, so now that's been taken care. Next stage is to grab some good wick. You can use good wick. I'll be using this Loctite copper braid, and start cleaning. See, what makes it difficult is you're recording as well as you're doing the work. I prefer not to sort of do this sort of work while I'm recording. What I meant to say is I prefer to do this work without recording because I've done many videos in the past. But I thought I'd upload another video since it's been quite a long time since last I did a repair. Just nice and gently. Get rid of all the excess solder. So effectively what I'm doing is I'm cleaning the pads. But I should have applied a bit of flux to ease the process. So that's what I'm doing, I'm just applying a bit of flux. Sadly there's a lot of background noise because there's many extractor fans are running. And I'm wearing a mask as well, because I don't want to be inhaling all this crap. Nice and gently hovering over, don't press on it. Just let the tip glide. Believe me, you don't want to be hovering over. Well, sorry, you don't want to be pressing on the actual thing basically. Trust me, that's not going to be a healthy option now. I'm going to wait for the soldering iron. Let me grab a let's put this back. Okay, that's it. That's the cleaning side is done. I'm going to use some alcohol and first I'll use some cotton bud and alcohol to clean the surface of the PCB. So cotton bud. Get rid of all the excess flux. I have seen people using lint-free pads and wipes and all that, which is perfectly fine. It's no big deal. Take the mask off for now. Grab a foam. I did have a foam somewhere here, which is what I got off Jimmy from Insight International. You'll find him, if he hasn't got any, you'll find him, but just contact him. eBay user ID used to be Bga Rework. I think it's been renamed to e-batteries or something like this. I will reuse this, so I'm not going to throw this away. Throw the cotton bud away and keep this foam clean. Okay, so just what I'm doing is I'm squeezing all the excess dirt out of that pad, and then what I might do is just go for one more. And what that does is that doesn't leave any lints. That's the whole idea of doing what I'm doing basically. Okay, so that's been taken care of. Put this back. Give my hand a clean with IPA. Just be careful when you're buying hand gel for the like the alcohol gel. Just be careful. Get something decent. Don't end up getting cheap bullshit hand wash, hand sanitizers, because your skin will start irritating. Right, so as you can see, nice and clean, and the new chip is ready to go on. Okay. So zoom back in. Right, and we're ready to put the new chip on. So what I'm going to do first thing first is apply a thin layer of flux. Just ever so thin layer. Okay, not too much, because what will happen is the chip will start getting lifted. So that's something you've got to be careful. What you can do is put thin layer, let the reflow happen, and then reapply a bit of flux again, and just rerun the, not the full profile, but just right. Right, what you do is apply a thin layer of flux. Then what you want to do is you want to sort of you can run the profile, because if you put too much flux on, then sometimes the chip gets lifted, and that is definitely a good, not a good idea. Okay, so let's position the chip to find the orientation of the chip that was originally on. It's a bit of, yep, found the orientation. That's perfectly fine. Perfectly fine. Let's sort of put a bit more of a layer of Kapton tape on the chip. I've covered the chip with full Kapton tape, just to prevent any excessive heat damaging the actual chip itself. It's always worked for me, so I stick to whatever that works for me best. Now, of course, one thing will work for me, the other thing won't work for you, so you just find your best way of doing things and you apply it. That's what you do. This is just a reference video. You pick up on that reference video and you do your own thing, your own way. It is as simple and easy as that. There's no I'm not here to debate what's right and what's wrong. Okay, so let's make sure the orientation of the chip is right. So just get this one more time. Because I put the layer of Kapton tape, I can't see the writing clearly. Right. Obviously there is an arrow which you can follow. Let me position this to the best of my ability. With you know, it's late in the evening here in the UK, so I am tired. I have no plans to work on it, but since the board has been baking, I've got no choice but to carry out the process, because otherwise I'll be back to square one again from tomorrow, and I don't want to do that. Just want to get it out of the way, get it done, and hopeful that the repair attempt has been successful. Okay. So the arrows matching, it's within the box nicely. Now I'm about to run the profile, so I'll bring up the upper heater, and just to make sure that it's in the center. So let's open up the profile. Yep, the chip is in the center. It is in its right orientation, and as far as I'm concerned, it's nice and straight. Yeah, that will get drawn. That will get drawn into its place basically. If it's ever, you know, it is probably 0.01 mil off basically, but that'll get back into its position. So I would not even bother. Let's just set the height of this. Make sure that the thermocouple and the chip hasn't moved. And then hit the start button, run the profile. Zoom in out to show you that the profile has been run. There we go. I've started the profile. So what's happening, the lower heater is preheating the PCB just to prevent it from warping. And then what will happen is that as soon as it reaches finishes the preheat session, what will happen, that's set at preheat set at 150. What will happen is then that the upper heater will kick in from 150, and the lower heater will start reducing its temperature to whatever the machine is designed to do, and then the upper heater will take. But however, the lower heater will stay on at a lower temperature basically, just to keep the board preheated from the bottom. Alright, so let's go and have a look at the chip. Okay, there's the chip. I'm going to pause the video only because that I just want to allow the temperature build, and I don't want this dragging on for hours and end basically. So I'll see you shortly. Let it preheat, and as soon as it hits about 200 degrees Celsius, I'll do that. Just I'll do what I need to do. Just one other thing to remember is that when you're nudging, just nudge it ever so slight, and do not leave the device on this machine, the PCB on this machine, like the Bga, for 30 seconds, 40 seconds. No, you don't. Only for about 5 to 10 seconds. As soon as the reflow has happened, just take the upper heater away as quickly as you can, basically. So if I feel that I need to sort of run another reflow by adding more flux, then I will do that, but I'll let the board cool down to about 180 before applying for another thing. Yeah, I might do that actually. So if I do that, obviously I'll catch that on the video. Right, one of the thermal couple has reached 200 degrees Celsius, so chip hasn't dropped. The chip will drop actually once it's running a reflow stage. I'm going to keep a close eye on the solder ball just to see if I can spot them and the chip dropping basically. Yes, some part of the chip has actually dropped. Okay, 217, 218. Yes, I can see the chip dropping. The chip has dropped. I'm going to do a small nudge test. Yep. So what I'm going to do is I'm going to shift this upper heater, get that going, turn off the profile for a second. I'm going to grab some flux, and I want to rerun that profile again. Only because that there has been instances where in the past that the chip hasn't soldered properly. Now if you put too much flux in at the beginning, it will lift the chip off. If you put as much flux as you want now, it doesn't matter. But it's the initial reflow you've got to be careful with. Just be careful that the chip is still liquidous. And I am going to turn the profile back on again. That's just me doing my things my way, because it works for me brilliantly. Right, so let's sort of wait. It's 210, and this time around I'm going to do a nudge test again. Okay, just going to wait for, turn the profile off, and I am going to move the upper heater. Very happy with it. That's it, that's done. Yep, the chip is nudging forward, backward and forward. So as far as I'm concerned, that's done now. Profile switched off, the upper heater's been moved. There we go. There's no room for 30 second and 40 second and 1 minute and whatever bullshit that some people tell you to keep that chip, because you'll fry that chip. That chip will just pop. It'll make a crack or a pop noise, and that's the end of that chip basically. So what's the way to prevent that is, as soon as you've had a successful reflow, the chip is moving backward and forward when you're doing the nudge test, get it off. The upper heater needs to go. It needs to move immediately. And And as I said, the reason why I did the second reflow is that there has been instances where I've fitted graphic chip, applied a thin layer of solder paint flux, and power on no display, same problem. So what I've done is I've brought the board back, put the board back onto the machine, rerun the profile again, and bingo, the laptop is still working to you know, it's just on, it's still going. So as far as the customer hasn't certainly come back, and they're local people. If it did, I would get mithering off them basically. So yes, I know for sure that the problem hasn't come back. So and here we are, you know, everything's working as it should be. So just don't rush, because with this type of job you only get one good shot basically. There's a lot of things you've got to consider. The reason why I did the actual preheating is to try and avoid hitting the board with a thermal shock. So you're introducing 230 odd degrees Celsius on the PCB. There's internal contacts and traces running on layer upon layer. Now introducing large amount of heat suddenly will actually expand the board, which can actually rip out the traces internally. You will have absolutely no idea that they're ripped unless you have an X-ray machine and you know what you're looking for. So one of the reasons why baking is to get rid of the moisture from the board, and to my mind to get, you know, to avoid any unnecessary damage to the PCB due to expansion. So that's that. Obviously the chip is cooling down now. It's 140, 150 degrees Celsius. So what I'm going to do is I'm going to slowly, gently now introduce the fan for the, okay, and let that slowly cool down the board, okay. Because again, I don't want to turn the fan on right just after the reflow, because you're introducing again a thermal shock. I mean, I've done this too long now. I know my way around it. Sometimes I do forget things to mention, but if I do, leave a comment below and I will get back to you. But otherwise, that's it really. There's nothing much to say. What I'm going to do is I'm going to leave the board around about 100 degrees Celsius and take it onto the bench, just so that I can peel off this aluminium foil with ease. Because if the board gets cold completely outright, it's going to be very difficult to sort of remove the thingy. So just bear with me. Let me just sort of turn some of these things off. Yeah, it gets a bit smelly because of all the flux and everything, and that's one of the reasons why I'm using a carbon filtered mask basically, which I initially bought for biking, but steam builds up in my jawbreaker sunglasses, so I'm not big fond of sort of using these outdoor anymore. So as a result of that, what I've started doing is I'll be sort of using it in the rework, with the rework station. Okay, here we are. That's the board that's been prepared. So I'm going to start peeling off these, and then I'll come back to you. No, I know you're probably going to say, well, what a shithead I am, you know, but I had to put these foils over. It's taken me quite a bit of time to peel them off, but you know, I just didn't want to sort of expose any heat, unnecessary heat onto these components basically. Does it really matter? Maybe not. These components may go through several hundred degrees Celsius when it's going through a the ovens for reflow oven basically. So but that's in the production line. This is where I don't have thousands of boards on the production line. If one fails, then whatever, you know. So I've only got one shot, so I'm going to take all precautions to try and avoid any unnecessary damages to the components in the board, on the board itself basically. So that if that means that I've got to spend 10 minutes peeling off foils, putting foils on and peeling them off after, so be it. It does not concern me that. So yeah, that's what I'm at. Put these plastic taping back on its place, front and back. including this pad. And one thing I did forget to do is to remove this bracket basically, but it didn't fall off, although it was the temperature on the board was quite high. It just didn't come off. So ideally what I would like to do is sort of take that off. The CPU has been cleaned, so what I'm going to do now is apply some thermal paste. I'll put the CMOS battery back in, apply some thermal paste. I'm using the MX4. Let's just put a little size of a rice grain. That's massive. And I don't give a effing crap about how much thermal paste I put in. That is the least of my worry at the moment. So I'm going to cut out a little pad, thermal pad, and apply that on top of the GPU. Okay, let's sort of okay, get this off. Like a clear taping on these thermal pads, so just be wary that when you're taking, you do take both layers off. Right, just be careful. Just nice and straight. Okay. Where's the thing gone? Just throw them in the bin. There's the heatsink. See the Jovi machine. If you do have a Jovi 8500, since the last firmware update, while the company was in business, what they've done is that the fan keeps on coming on quite often. So just don't rush and switch off the machine from the mains. Leave it running for at least an hour. Let all the components that the fan cools down to be cooled down. So I've already cleaned them, but I'm still sort of give it another wipe. Okay, so the heatsink goes on. One thing I didn't check is under the microscope what the solder joints look like. So let's inspect that under the microscope, which you can't see, so pointless recording. Show you what I just did there then. Just going around the edges under the microscope, making sure that the chip is nice and flat around, so one side is not been lifted or one side is higher than the other side. It's beautifully lined up basically. Of course I'm not praising about my own work, but I know what I'm good at and I know what I'm not good at, so that's just the way things are. Okay, so let's grab a Phillips. I don't want to be pressing down on the actual board, because I can quite easily damage the newly chip by pressing it down too hard and lifting one of the solder balls, or the pads gets ripped out, whatever it is that. So again, there's a lot of thought process that goes in doing what I do. How successful is the repair? We'll find out pretty soon. Okay, so let's create some space. I'm still gonna, like I said, I'm still gonna leave the Jovi power on for at least another half an hour or so. Okay, so what I need now is the power switch, which is here. I will also need the LCD assembly. I'm just looking for it. Oh, yeah, I found that. Okay, I have found it. Yes. Excuse me. Just hope that everybody around the world, wherever you are, you're staying well and safe. Let me grab this high temperature mat, which also acts as an anti-slip mat, so nothing can thingy. I've just spotted a bit of a flux. I am going to do a proper testing on it, Firmac and everything else, once the board has posted successfully, but until then nothing's going to get done in a proper manner. Sadly, I'm struggling to sort of this is just for experimentation, so that's the reason why I'm doing what I'm doing. Okay, just make sure that the board nothing is touching, any components are not touching the metal hinge. In fact, I'll do it like that. Okay, that's okay too. Let's get the DC jack. Okay, find the charger, whatever it is. I hope you're getting all this. Yes, of course you are. We're in 3 minutes into recording. Let's grab my power supply. Whether that matters, I don't think so. Let's get my power supply. Let's get rid of this microscope. Okay, just make sure that there's no metal bits floating around. Make sure that I've taken all the aluminium foils off. So that foil is conductive, so it can fuck up your board. Let's just do one more final inspection on the back. Okay, there's no foil anywhere that I can see. Okay, moment of truth. Let's power this beast up and see what happens. So, I do have a light. That blinked. I don't know why it did that. Okay. So we have okay, and we have display. Yep, beautiful, beautiful. Okay, so the graphic chip repair has been successful. To prove my point, let's sort of boot into operating system, because that could be, some of you might say, yeah, that's just false thing. It'll crash out and it'll do this and it'll do that and all that business. So what I'll do is, let me insert my testing hard drive. That's providing that I can find that piece of shit. There it is, Windows 8.1 testing drive. Powers off. Okay, that's not the one. So where is the hard drive thingy? Basically, this. Right. Okay. I see what's going on. Right. Let me reassemble the laptop. Okay, and I'll come back to you. Okay, just bear with me. Just reassembling the laptop back together. And then I'll carry out a thorough test. I won't put all the screws on, just a couple of screws here and there, basically, and then start sort of doing further tests on it. So let's grab all the screws and all the thingies that I need to have in hand. The Wi-Fi card, I think, goes in the underside, so that is not a big worry. What next would be the palm rest, and there is some speakers. That would be on top of the palm rest, I would imagine. Right, okay. So, and then the LCD sits on it. So let's just make sure that I'm doing everything and I'm not missing any screws and this and that out, because I know for a fact that if I do miss something out, I can assure you that the whole laptop will be dismantled and it will be done proper. Okay, so if one screw's missing, yes, it's going back in its place. I'm not. I know you might probably say, you what a fucking lunatic you are, basically. Just fuck it. Nope. It's the moral, it's the principle that, to me, that matters more than anything. So that's what's gonna be. That's how I live my life. That's how I do things, and that's how things are going to be planning out for me now and in the future. That's me. Okay, so again, I don't want to waffle on showing how to dismantle this unit. Let me put it back together more and I'll catch up with you. Laptop's been put back together. I'm just running a quick firmware test. This test will carry out all day tomorrow. Basically just to ensure that the stability of the laptop itself, and basically For a couple of things to sort of bear in mind when you're doing graphic chip repairs, if you're prepared to do that, is when you're buying chip, make sure that these are sort of original, genuine chip, and you will know when you look at the chip that the color of the PCB should be nice and whitish, greenish, not dull green, greenish basically. So do sort of watch out for that. Look at my sort of previous videos that I've done over the years, and you will find what to look out for. Bake the board for at least 3-4 hours at 90 to 95 degrees Celsius. Nothing above that I wouldn't recommend, because these electrolytic capacitors are surface mounted capacitors on there, and you can very easily damage them. That's one thing. And once you've done the baking, don't let the board cool down. Preheat the Jovi as I've done for 5 minutes. Let the upper heater and the lower heater sort of build up the temperature, and then once it's preheated for about 5 minutes, don't hit the I have seen some that just hitting the preheat heater 100%. Don't do that. You'll very easily damage those elements on and the heaters basically. Just set it to about 55% on all three manually on the Jovi software, and apply and then start the profile, and just run it for 5 minutes manually. Once you've done it for about 5 minutes, don't let the Jovi cool down. Okay, just take the board out of the oven, bang onto the top of the Jovi, run the profile. This is why I did the foil masking and everything beforehand, basically. And then you know, you're not introducing any kind of a thermal shock on the board, and just run the profile accordingly. Take the chip off. Again, don't let the board cool down too much or for too long. Get rid of all the excess solder, apply a bit of flux, put the chip on, run the profile. Once the profile has been achieved and the chip has done this nudge test, I would urge you to apply plenty of flux and rerun the profile. So let the temperature drop to about 180 degrees Celsius, okay, and move the upper heater, let it drop, apply flux, put the upper heater back on, rerun the profile again. Make sure you do that nudge test again, because that extra bit of flux what you put in secures a solid joint under the chip with this old tiny little solder balls, and I can assure you that helps a lot of Bga Rework being successful. In the past, I have myself have experienced that when I've tried doing a graphic chip repair, putting too much flux means that as soon as the flux activates and it's reached a certain temperature above 150, near 200, it kind of lifts the chip and it sort of tilts. Okay, so that's one of the reasons why I wouldn't recommend to put too much flux. Only a thin layer, apply it on, let it reflow. Once you've done the nudge test, shift the upper heater, put plenty of flux around. Make sure you don't nudge the chip, whatever you do, because you will put that line. Just put the syringe and just put, you know, go around the edges, but without touching the Bga chip with your syringe tip, basically. And then just put the upper heater back on the top of the chip. Rerun the profile until it reaches about 220, 230 max. Leave it there for about no more than 5 to 10 seconds. Nudge test and make sure that the chip is moving. And once that is achieved, quickly shift the upper heater. Turn off the profile, let the board cool down to about 150 degrees without introducing the fan. Once it's reached 150 degrees, introduce the fan, and that'll cool down the board. You can leave it on. Do have fume extractor, wear gloves and wear glasses, just in case any solder spitting can happen. And one thing to look out for is never to leave the upper heater longer than 5 to 10 seconds once you've done the nudge test at around about 225, 230. Take it off, because the chip will get fried. These Jovis are very, very sensitive, and they're very effective and very penetrative heat, because it's using dark infrared technology. It's not hot air. Hot air stations are much more friendlier than dark infrared systems, so you've got to be on the ball with these sort of systems, basically. Rework system, and hope for the best, and just you know, let the board cool down, give it a good clean, put everything back together, and the moment of truth will come out, basically. The saddest thing is that what the Chinese markets are doing is they've flooded with refurbished chip, reball chip, and that's what you've got to be careful with basically when you're buying chip off eBay and AliExpress and Alibaba and all that business basically. Right, I'm going to stop this now. Okay, and let's just, so I was hoping that I had a software that can actually monitor the temperature, system temperatures. I've got 60 degree CPU, that's perfectly fine, but I wanted to see what the GPU temperature is, and I did have a program, hardware something, but that's not showing anything here. Right, okay, so that's not good. It's not showing me the temperature of the graphic chip basically, which is no good. So I'm going to go under the assumption that it'll be in the region of 60, 58, 60 degrees Celsius then. That's the temperature that's it's operating on. I did have a program that I could have tested the temperature, but I'm just trying to, can't think of, my head's not right at the moment. I'm absolutely shattered, absolutely shattered. I don't think the ATI, no, that's an NVIDIA. Yes, it's an ATI. Just disregard this. It's an ATI 44200 mobility chip, basically that. So I'm not going to bother with installing the full driver. There's no need for that. It's already got the driver installed. That Windows downloaded it and installed it basically. The utility's not been installed, which is not a big issue. So yeah, that's all really, guys. I'm going to upload the video soon, and hope for the best. You stay well, stay safe, and you know, just take it easy. All right, take care. Bye for now.